Okay, some of the problems you're going to be seeing here pretty soon in some of our formulas we're going to be working is this is going to be at the start of one. Now, this is where we're going to use our formula, all the stuff I showed you in the first video. So what we're going to do here is we have a jar, and we have a force that's going to be pushed down on top of that jar. We have our fluids that's going to be inside here. That's going to be pushing fluid in all different directions. So it pushes it out. If you read Pascal's law, fluid is pushed undiminished to all corners of the area. So what we're doing here is we're going to try to figure this out, see our pressures and our areas and our force. Like I said in the first video, you have to have at least two of these to figure something out. I know it looks a lot like algebra from your high school days, and I'm sure you're looking at me saying, when am I ever going to use this? You will, but you always have to have two variables in this. You have to have one of the, two of these to figure something out. So let's say we know our force. Okay. Now, if we know our force, we're going to say it's 5. Or no, let's say it's 10. We have 10 pounds of pressure pushing down on this fluid. And we have 100 pounds of pressure. Okay. Now, how do we go about this? So we have force pressing down onto the cylinder head, and we have the pressure that this force is causing by pushing down this fluid. So we have force, we have pressure. We don't have area yet. So the way we're going to do this is by using our formula. We're going up and down. If we go up and down, what do we do to figure out that area? We divide. So we force divided by pressure is going to equal our area. That's what we talked about in the first video. So 10 pounds of force divided by 100 inches of area, or I'm sorry, 100 pounds of pressure. I want to take my trusty calculator again. So we have 10 pounds of force divided by 100 pounds of pressure. That's going to give us an area, meaning this cylinder on the top, even though how big it is 0.1. So this is 0.1 of an inch. So it's a small cylinder. But that's how we figure that. Now, we can take away our pressure. And now we're going to change everything up, because that way we can have different areas to do this. We're going to say, we know our area now, so we're going to say 100 pounds of force this time. Our area, we're going to say 15 inches. That's a big cylinder. 15 inches across the top, the head of that cylinder. So, force is the pressing down against the top of that cylinder. That's the 100 pounds worth of dirt we got in the bucket. The cylinder head that the rod is pushed down on with all that weight is 15 inches wide, or round. Remember how we talked about the bore times 0.7854 gives us our area. The area of that cylinder is 15 inches. 15 inches this way, 15 inches that way. So, we know that, but we don't know our pressures. Again, Same thing. Up and down, we divide. So I'm just going to replace these two with force divided by area equals our pressure. So 100 pounds of force divided by 15 inches of area gives us, and I'm going to round up again, 6.67. That's how much force or pressure we have in the system. That's the part you want to make sure you get right, is the difference between pressure and force. The force is always what you're picking up, what's pushing down against the fluid. How much does that dirt weigh? How much does that rock weigh you're pushing against? How much is the dirt weigh that you're dumping out of the back of the truck? That is our force. Our pressure is what's inside the system. That's the two you got to remember, because that's usually the two that gets that way mixed up. Is sometimes people want to say the force inside here pushing against the cylinder. It's not. It's what's pushing down against the oil. Make sure you remember that. All right. So that's the two different ways to do that one. But what happens? Oops. If now we don't know our force, which we'll say we have 10 inches of area, and we have 150 pounds of force, or not force, excuse me, 150 pounds of pressure in the system. Now, our little saying down here, side to side, we multiply. So, we know our pressure. We're going to times that by our area, which we know, which is going to equal our force. So, 10 times 150, which it don't matter which way you put this. In multiplication, it never matters. If this one's here, that one's there, it still equals the same thing. So, this is 10 inches times 150 pounds equals 1,500 pounds of force pushing down on top of the fluid. Now, the smaller you make the area, of course, changes the pressure. But as right now, with 10 inches of area, 1,500 pounds pushing down on top of that area will build 150 pounds of pressure. Or 150 pounds of pressure holding back. How can 150 pounds hold back 1,500 pounds of force, of dirt? How can it hold it up? Because that's what we're trying to do. We're trying to hold this dirt up without it pressing down and we'll just go ahead and make it this way. Blowing out the side of that. So, what we're saying is fluid cannot be compressed except for just a tiny, tiny bit. Air, you can take a big bundle of air and press it down to a little bitty old tiny spot. And the only thing it does is build heat. Fluid, on the other hand, cannot be compressed except for .04%. That's tiny. The only thing that is pretty much like the molecules squeezing together or little air pockets kind of getting squeezed together. That's it. So, if we have too much here, let's say that this pressure, or this, not the pressure, but let's say the force pressing down is 2,500 pounds. If we have 2,500 pounds getting pressed down onto this fluid with 10 inches, this would be 250 pounds. Now, if this container can only handle 150 pounds worth of pressure, that's when we have a blowout. That's why we got to go back to the second video with the volume to be able to figure out how, and the pressures and stuff, so we know how thick the sides need to be, how long it needs to be, how big or round it needs to be, so we won't have a blowout. So, now, we have that one down. If there's any questions, please email me, and we'll work through these, and I'll send you another video.